Okay, our next question is going to be question 9 on page 133. In this question, let me read for you that in the figure above, not drawn to scale, TF is perpendicular to FY. Fx equal to 40 meters and xy equal 20 meters. And angle TXF equal 42 degrees. Calculate. Correct to two significant figures. 1. The length of TX, and 2. Angle XTY. So here they pointed out to us that Fx equal to 40 meters, XY equal to 20 meters, and that angle TXF equal to 42 degrees. They also pointed out of interest that TF is perpendicular to FY. And let us highlight that now by putting in this highlighting that TF is perpendicular to FY. Solution. Take triangle TFX. This is triangle TFX, and we are going to base our solution on this. We were asked to find TF, and the triangle that gave us the most information to find TF is triangle TFX. Therefore, we need to highlight the given angle. This is the given angle of 42 degrees. The given angle of 42 degrees allow us now to label the triangle with the opposite side, the adjacent side, as well as the hypotenuse. The side opposite the given angle is called the opposite, and the side where the right angle and given angle are on the same side is called the adjacent. Therefore, TF is the opposite side, and they also gave us Fx, which is equal to 40 meters. Now that is the adjacent. We are going to put the summary of all the trig ratios, so-called tau, and then we are going to decide which trig ratio will use the opposite side as well as the adjacent. It will not be the sine ratio, it will not be the cos ratio, it will definitely be the tangent ratio. Therefore, tan theta is equal to your opposite over your adjacent. And we are going to use this ratio now to go ahead and to find the side TF. Substituting the values in, that's tan 42 degrees. We're going to replace the opposite with the side TF, and we're going to replace the adjacent with XF. That's 40 meters. So tan 42 degrees equal TF divided by 40 meters. Here we're going to try to cross multiply to get TF to be the subject. So we multiply TF by 1, so that's TF times 1, still gives us back TF. Then that's 42 degrees, tan 42 degrees times 40 meters. Now we are going to find the value for tan 42 degrees. Now find the tan of 42 degrees. Remember, check that your calculator is in the right mode, and as I'm highlighting here, check that your calculator is in fact in degrees, and then simply let's find the tan of 42 degrees. So tan of 42 degrees is going to be equal to 0.9004, and working with 3 decimal places, this would be so that it's going to be that TF is going to be equal to 0.900 times 40 meters. So TF is going to be equal to 36 meters, corrected to 2 significant figures. Alright, let's continue with our solution. Find, and this is part 2, find angle XTY. Now we are going to identify where angle XTY is, and this is identifying that, so therefore we identify the angle to be here. Now we can't work directly to this angle based on what we have done in class, so therefore we have to work around to get this angle. And so to do this, what we are going to do is to take triangle TFY, and this is triangle TFY, where we're going to go to find the overall angle. That's the entire angle here, as it is FTY, and then we are going to use this to find the required angle, right? So we're going to use this angle here, this one, which is the overall angle, to find the required angle. So here we are. Fy equal to 60 meters. Let's follow this. So we understand that if we have fx plus xy based on the previous diagram, added together, that's going to be 40 meters plus 20 meters. So Fy will be equal to 60 meters. Now continuing, find angle FTY. We were told that TF, or we found earlier that TF was equal to 36 meters. And also they gave us that Fy is equal to 60 meters. So now we need to look at the angle that we are trying to find, which is a required angle, and we are going to use that to label the triangle that we have so far. So this is a required angle. In that case, we see that the given angle, or the required angle in this case, and the 90 degrees angle are on the same side. So the required angle and the 90 degrees angle are on the same side. So therefore, that is going to be our adjacent side. And also, we can see that opposite to the given angle, our required angle, is Fy, which is 60 meters. So therefore, the sides we have here is the adjacent and the opposite. Now, which trigonometrical ratio uses these two sides? We're going to put the summary here, which is SOHCAHTOA, and then we are going to now decide out of that which trigonometric ratio, which trig ratio use the adjacent and the opposite. Hypotenuse is in the sine ratio, so we won't be using the sine ratio. Also, the cos ratio uses the hypotenuse, so we know that definitely won't be it either. So we are left with the tan ratio. So that is going to be tan theta equal to opposite over adjacent. Continuing. So therefore, we are going to now substitute the angle that we require, angle FTY. And we are going to replace the opposite with the 60 meters, because that is the Fy, which is our opposite, and then our adjacent side is the 36 meters. So we have now 60 meters divided by 36 meters. That returns a value for us of 1.667 written to 3 decimal places. We are going to find the tan for this, the tan inverse for this. And what we're going to introduce here now, this is a tan function, as you can see here, except we're not interested in that, because once we want to find an angle, we must use the tan inverse function. So once we want to find an angle, we must use the tan inverse function. So we introduce the tan inverse function. What that does, it moves the decimal to the side where the tan inverse function is, and move the angle to the other side. So therefore, we now put this information in our calculators, and then we would find the tan inverse of 1.667. We would see that the tan inverse of 1.667 is equal to 59.04 degrees. We have to do some more sorting out of that, and so therefore we are identifying that we're going to write this angle to 59.0 degrees. So that's the overall angle here in broken line, and then we need to get to the required angle. To do so, let us take out the triangle TFX and see what the angle FTX is. We understand that the rules from the rules of triangles, that the sum of the angles of a triangle equal to 180 degrees. That's what this is. So 180 degrees minus the 90 degrees, which is here, plus the 42 degrees, which is given here. So that's equal to 180 degrees minus the sum of the other two given angles. That will leave us with, that would be 180 degrees minus 32 degrees, 132 degrees, which leaves us with 48 degrees. So therefore the angle that is going to be angle FTX is equal to 48 degrees. The difference of this now will give us the angle XTY. So angle XTY equal to 59.0 degrees minus the 48 degrees, which is going to be equal to 11 degrees, and this is corrected to two significant figures.